For the past few years, we've recognized it's very difficult to just take a camera and take a picture of a scene and then look at it and really capture what you had seen. So instead, with the ubiquity of video cameras and cameras everywhere, we realized that taking lots of pictures, maybe a video sequence, maybe a lot of pictures taken with a still camera, through the magic of computation, either on a machine or up in the cloud, we can enhance the experience. All right, so I want to show you in particular how we created this image. If you've lived in Seattle for any part of your life, you've certainly seen Mount Rainier. And the first thing you might be asking yourself is, where was this picture of Mount Rainier taken from? And I'll try to explain that. So if you look over here, what I'm going to show you is not just one input image, but many input images. I set up a camera in downtown Seattle, and this is what I saw through that camera. You'll notice, because the lens was so long, that the mountain appears to be shaking around. And that's because when you have a very long lens, it's almost impossible for the camera to stand still. In addition, the atmosphere, of course, makes things shake. And here we took all those images and used the computer to align them so that it doesn't shake so much. But you can still, if you look carefully, you'll see the atmosphere is shifting around and all the pixels are changing. Finally, we can go in and we can move every individual pixel by itself to get them all nice and aligned. And now we finally have a nice, stable image of Mount Rainier. But it doesn't look as clear as we'd like, so we can do some magic, which we call dehazing, and we get a result that looks like this. Unfortunately, in order to get this dehazing, you'll see a lot of different artifacts in here. You can see dust spots from dust on the lens, and if you look at the mountain, it doesn't look very sharp in all the places because of what we needed to do to expand the contrast. We can take all of those images and align them, as we saw before. Once they're aligned, somewhere hidden in there is a much sharper image and a much richer image. And now, if we dehaze that result, we get this. For example, if you see the sky, most of the dust has been removed, and if you look at the mountain, it's much sharper. And that's the reason is because if we look at every single pixel here, what we did is we relied on something we call lucky imaging. It's something we borrowed from the astronomy field, where when they look at stars, even though you see stars twinkling at night, that's because the atmosphere is moving things around. But every now and then they get a very lucky shot of that star. Unfortunately for us, we have a whole mountain we want to make a picture of, so we need to get lucky on every place on that mountain. And through computation, we're able to examine the pixels for every location on that mountain and pick out the 1 or 2 or 3 or 4 where we get lucky, so to speak, and get a nice sharp picture of that image. Finally, you put it all together and we get this result.